this is another one of our series on Laplace transform calculus and calculus with Laplace transforms. In this one, we're going to look at, in particular, convolution. Okay. Now, the thing about convolution is, let's get this working. Is that this is we're asked to find the function h of t. This is the name of our function, which is the convolution of two given functions. So we have essentially we're given f of t and g of t, and this operator here, this little asterisk here, indicates that they are we convolute them, so to speak. Now, convolution is a sort of particular mathematical operation that is, I won't get into it here. I'm actually just going to look at it from the point of view of Laplace transforms and how to solve it using the formula sheet. So f of t, convolution of f of t and g of t, and we are asked to sort of determine what h of t is, therefore. Now, thing about we're going to look at this from the point of view of Laplace transforms. So, what helps us here? The fact that these are the Laplace transforms of f of t and g and t respectively, f of s and g of s, and so if we multiply f of s times g of s, we can determine h of s. That's the Laplace transform of h of t. Okay? So essentially, this problem actually gets simple enough relatively quickly. We determine the Laplace transforms f of s and g of s, and then multiply them to determine h of s, and then we find the inverse Laplace transform of h of s to yield our solution. The solution we're looking for is h of t. That's what we have to find out. So let's look at an example here now. Find h of t when h of t is the convolution of these two functions here. F of t is e to the power of t, and g of t is e to the power of minus t. Okay, so first off, let's get the Laplace transforms of each. So this is the Laplace transform of the first one. So we're going to use the tables for this. Simply e to the power of t, the Laplace transform of that is as follows: 1 divided by s minus 1. Something similar for the second one here. G of t is e to the minus t. So the Laplace transform of that, g of s, is 1 over s plus 1. Now, just if you're wondering, on my website, these are coming from mathematical tables. I think they're entries up at the top, entries 2 or 3 or something like that, right up at the top of the tables. Essentially what you're looking for, e to the power of at, the Laplace transform of that is simply 1 over s minus a. Just as a remark, this, just while I'm mentioning it now, this series of videos is intended for a course where you do a few things by first principles, but a lot of the later stuff you just use tables, just in case you're wondering. Okay, now we have f of s and we have g of s. Let's multiply them out, and simply we have 1 over s minus 1 times s plus 1. Okay, so that's the difference of squares. Okay, or if you want to just multiply it out by the long way, you can do that as well. But essentially what we'll find here, and this is an important part now, is h of s is equal to 1 over s squared minus 1. Okay, what we're going to do now is use the formula sheet again and sort of see which one of the structures there would help us. So this is one I'm particularly interested in. Now, there's multiple answers to this, by the way. You can actually approach the problem from several different ways, and you probably will get several different answers that are actually mathematically equivalent when push comes to shove. This is what I'm going to use in particular. Entry 6. And what I'm going to say is that a is equal to 1 and a squared is also equal to 1. So there we have 1 over s squared minus 1, or or 1 squared. That means, working backwards, the hyperbolic sine, or sinh, as some people call it, simply hyperbolic sine of t, where a is just 1. At equals 1t equals 1. So the answer is, here I have it written out, the answer is that there. So actually I'll just write it here again. F of t is the hyperbolic sine of t, or sinh t, if you like that expression. That's the answer to the first one. Let's go look at the second one here. I have a second example just to sort of... it's the same structure to this question. In this question, f of t is t and g of t is t squared. Okay, so we have f of t and the f of s. The Laplace transform of that is 1 over s squared. This is again from the tables here that I'm doing these two examples. G of s is, if g of t is t squared, g of s is 2 over s cubed. Okay. What we're going to do now is multiply them out, f of s and g of s. So we find that h of s is equal to, so we multiply that out, 1 over s squared times 2 over s cubed. And that is equal to 2 to the power of s over 5. Okay. Now, importantly, that's h of s there. Importantly, we have to sort of come up with a sort of way of finding the inverse Laplace transform of that. Now, what we're going to do is use a different structure in the formula sheet. Now, we're going to use this one here. But this is one that's also up at the top of the formula sheet. What I've done there is actually added in an extra constant there, k, just to emphasize that you could have a sort of a scalar multiplication of your expression, and you have to find out what k is as well. So first off, we're going to write this 2 over s squared, s to the power of 4, necessarily s to the power of 5, and that's in the form k times n factorial. I'll write it up here at the top, or over here, k times n factorial over s to the power of n plus 1. What we're going to do is sort of superimpose this structure on our... that looks like I'll just make that more S-shaped. Superimpose this structure here. So necessarily n plus 1 is equal to 5. Okay. So if n plus 1 is equal to 5, n is equal to 4. And we can further deduce n factorial from that. N factorial is 4 factorial equals 24. So n equals 4, n factorial is 24. Now we know that k n factorial is equal to 2, so we just have to solve for k there as well. That's equal to 2, so necessarily k is equal to 1/12. I'll just scroll down here for a second. Okay, so k times n factorial equals 2. We know that n factorial is 24, so k times 24 equals 2. That makes k 1/12. So the solution of the inverse Laplace transform is this, and that is k, so let's just write it out here, 1 over 12 times t the power of 4. Okay. So this is from the formula sheet. And in case you don't have the formula sheet in front of you, this is the inverse. This is k times t to the power of n. That's the Laplace transform of that. K times t to the power of n. I probably should have had that in the sheet there, or on the page in front of you as well. It's one of the top ones of the formula sheet. Formula sheet is on. I'll just scroll back up here and just tell you the name of the website that has the formula sheet. It is simply mathsresource.com. Okay, that's a wrap. Thank you very much.